Let's now define such numbers. Such numbers are called irrational numbers. Irrational number. A number is said to be an irrational number if it cannot be written in the form p by q, where p and q are integers, and q is not equal 0. They are denoted by q bar. Some examples of irrational numbers are √2, √5, 0.6427227227. Herein, 0.6427227227, 7 is repeating again and again, so it is indicated by bar. Notice that √2 cannot be represented in the form of p by q. Though we can represent in form p by q, that is √2 by 1, which is incorrect, because √2 is not an integer. Now keep all the irrational numbers with rational numbers. Do you think, are there any numbers left on the number line? No, the combination of rational numbers and irrational numbers forms a complete number line. So we can say that the collection of all rational numbers and irrational numbers together makes a collection of numbers called real numbers. Rational numbers plus irrational numbers equals real numbers. Let's now look at the real number line. Up to now, you studied what are natural numbers, 1, 2, 3, 4 and so on, whole numbers, 0, 1, 2, 3, 4 and so on, integers, 0, 1, 2, 3, 4 and so on, and -1, -2, -3, -4 and so on, rational numbers, 5 by 2, 1 by 4, 45.5, -6.5 and so on, and irrational numbers, √2, pi, -5 by 4 and so on. Now look at these numbers on the real number line. In this real number line, the numbers 0, 1, 2, 3, 4 are whole numbers. And the numbers, -15 by 4, -2.5, 20 by 9, and integers are rational numbers. And the numbers, √2, pi, -5 by 2 are irrational numbers. Thus, a real number is either rational or irrational number. Every real number is represented by a unique point on a real number line. Also, we can say that every point on the real number line represents a unique real number. This figure shows a real number set diagram. So, a real number set consists of all rational and irrational numbers, 0, positive and negative numbers. Let us check out what we have learned till now. Is 0 a natural number? No, 0 is a whole number. Is 2 a rational number? Yes, because 2 can be represented in the form of p by q, that is 2 by 1. Is √5 a rational number? No, it is an irrational number because you cannot represent √5 in form of p by q. Is √9 a irrational number? No, it is an integer, because √9 is equal to 3. Let us summarize what we have understood. The numbers are categorized into positive numbers, negative numbers, and 0. The collection of all rational numbers and irrational numbers together makes a collection of numbers called real numbers,